the slope and rate of change. The key term or the name, you see it repeatedly. So rate of change again, I use different marker. Rate of change, slope, both they are the same, but just depends on the the representation or the formula that you use for that part. The difference quotient is another name of the slope. They all are the same. The way we call difference quotient, because we do based on the point. Let's see. You think about the other pair, right? For the slope is x1, y1, and the other pair x2, y2 as a generic 2 points for the slope, which y2 minus y1 over x2 minus x1. And the rate of change, it would be the function like the first function, the first point of time, like the f of x2 minus f of x1 divided by x2 minus x1. For the different quotient, instead of use the notation x2, y2, but they use x2, y2 in the form of the change that different from the original point. Original point x and fx, okay? So this one is referred to x1, y1. And the new order pair, that is your x2, y2. You see the difference? The x quantity is moved over a little bit by h value. So let me do different way. See the x here and the x plus h. For the real number line, you have x right there, and the next point is gonna be x plus h because it's away from the original x by h unit. Okay, and technically the x is your x1, the x plus h is your x2. Okay, now based on the slope formula, the y2 minus y1, that means you can rewrite y2 minus y1 as the function of x2, which is this portion, subtracted by the function of x1 and divided by x2 minus x1. Exactly the same pattern when you work with the slope formula, but use different notations. And what you can simplify would be the bottom one. I'm going to clean up a little bit. So the bottom, as you represent the second x as x plus h, or the change, the difference from the original point, you can simplify the h and h cancel and leave you just a single term as a h. Now you have another version of the slope formula as the f of x plus h minus f of x divided by h. And this expression is called difference quotient. Okay. And then for the following part, the different quotient, the slope, that's the same as the m or the m notation. In the second box here, the slope of a point at a curve. So you are talking a particular point, okay? Not generic x1, y1, not the any x, any y. Particular x equals a, y equals b. This box talks about the slope of a curve of the function at the particular point is exactly the slope of the tangent line to the curve at the point. Meaning you have the graph. I'm going to go with the graph here, okay? The graph y equals f of x, this graph. So this is the graph of y equals f of x. And you have the particular point, the AB, different one. I use this one. So this is a particular point A comma B. And this box means the slope of a curve, the curve y equals f of x. This curve the slope at the particular point is the same as the slope of the tangent line. So if you know the order pair on the curve, you put in this format, you can also use it as the slope of the curve. And the notation, I mean the way to represent the slope is the m, right? The m subscript tan is from the tangent line. So the m of the tangent line or the slope of the tangent line is equivalent or is the same as the different quotient when you take the limit as h approaches 0. Okay, the concept of this is if you have like 2 points like away from each other, you draw the line. This line is called secant line. When you move the h or move the second point closer to the first point, that means the gap or the h is very small. The h is getting smaller and smaller, but it's not 0 because you're going to have some gap, but the gap is considered very, very small. So then the secant line getting closer and closer to be the tangent line. Okay, and the tangent line, when you find the slope, we call the slope of the tangent line. It can be used to represent the slope of the curve. And then see the wrap up here. In the box, the slope of the curve, talking about slope of the curve, okay, at the particular point is the same as the slope of the tangent line to the curve at the same point, and also it's called the instantaneous rate of change, and also called the derivative of the function f of x at x equals a, and the notation is f prime at a. So it can be called 3 different names, but they all are the same based on the slope formula. Okay, the slope formula, rename it, rebrand it to be the different quotient. You take the limit and it represents the slope of the tangent line. And that slope of the tangent line represents the slope of the curve at the same point. In application, we call the instantaneous rate of change. See the different key term because earlier part of the package, we call the average rate of change because 2 points totally distinct. So you draw the line passing these 2 points, it's called the secant line. And the M of the secant line is the average rate of change. So I'm going to put the note here. So the note, the average rate of change is the same as the slope of the secant line. Okay, and the way that we compute the function at x2 minus function at x1 divided by x2 minus x1 as what we did last time. So when you put the limit in front of, or you take the limit of the different quotient, the secant slope becomes the tangent slope. The average rate of change becomes the instantaneous rate of change. Okay, kind of getting closer and closer to, and then the gap is so small. The cutting line becomes the touching line. The secant line becomes the tangent line. All right. Too much information, right? So we're going to get to the example in a bit. So at this point, now you are introduced the notation f prime. F prime is called the derivative. When you write the function originally, like y equals f of x, so this is called the function, okay? Function f of x. And when you put the prime, like the dash on the upper right of the notation f, or we call f prime, or the derivative of the f with respect to x, it is the slope of the tangent line at the point x comma f of x. This notation tells you, like, in general for any order pair, not particular at a, b, could kind of expand from the particular point to any point on the curve. Okay, for example, if you have the graph y equals x squared, this is a very classic example. You draw the tangent line at the point, let's see, at the point 0. The tangent line is a horizontal tangent, right? And the slope is 0. At this point, this is m equals 0. But if you pick the point on the left side here, you have the falling line, and this tangent line has the slope which is less than 0. If you pick another point on the other side, you have another tangent line that has different slope. Slope is greater than 0. So any point that you use along the curve will give you different slope of the tangent line. Does it make sense? I hope you are not too confused. Just more explanation here. Now, from this, just this part of information, stick with the f prime or the derivative is the slope of the tangent line. Okay. Now, if you have the input, the x equals a, you can compute the f of a that represent the height of the point or the height of the graph. But when you do the f prime at a, that represent the slope of the graph. So just represent two different things.